We'll get after it. Okay. It's been a while since I've done this. This was on the assignment that started on page 392, and we're looking at number 73 together. Ferris wheel. So a Ferris wheel 50 feet in diameter. Yeah. Am I frozen? I'm sorry. Unfreeze. All right, Ferris wheel, 50 feet in diameter. And it's probably spinning, right? Makes one revolution every 40 seconds. The center of the wheel is 30 feet above the ground. How long after reaching the low point is a rider 50 feet above the ground? Okay. So the center of the Ferris wheel would be here. So there's probably some kind of structure that's holding this thing up off of the ground. And the center of it is 30 feet above the ground. That kind of makes sense, doesn't it? So then how far would this be? That must be 5, right? Because we got 25 and 25 because the diameter is 50. That makes sense. Okay. And we're doing 1 rev every 40 seconds. So the question's asking about, we've got a rider on this thing, and it's asking how long after reaching the low point. So the rider's spinning around on this thing. How long after reaching the low point is the rider 50 feet above the ground? So 50 feet up would be almost to the top of the Ferris wheel, right? The top of the Ferris wheel will be 55, agreed? So it's going to be up here someplace. So we're looking at like a y coordinate if we're talking up and down. Agreed. And we know that we can, when we're talking about a circle spinning around, that the x and y coordinates can be represented by sine and cosine. We talked about that with the unit circle. And we talked about which one goes with x and which one goes with y. That's not so important. Just are we comfortable with the idea that their height is going to follow a sinusoid, either a sine or a cosine? So let's start making it. It says how long after they're at a low point. That makes me think that I want my sinusoid to be starting out at a minimum. Right, and so let's just go ahead and do 1 full period. This would probably be smart if I kind of drew my max and min lines in here. Let's do 1 full period, starting off at a low point. It would need to return to a low point, agreed? And we've learned that we can write an equation for any sinusoidal using sine or cosine. What are you thinking for this one, though? What would be our best bet? And I think a negative cosine, we wouldn't have to shift it at all, right? Left and right anyways. We do know where the center is going to be. We said it was going to be 30 feet off the ground. So this is going to be at 30. And we said that the low point was at 5. And the high point would be at 5 plus 50 in diameter. So this would be at 55, which means our amplitude is 25. All right, so we're looking at a cosine. We've got our amplitude. We've got our vertical shift. Vertical shift's going to be 30. Could you guys carry on this conversation? Yeah, thank you. Vertical shift's going to be at 30. We don't need a horizontal shift. What else do we? Oh, we're going to need to figure out how wide this thing is. How long does it take it to go from a low point all the way up and then back to a low point? 40 seconds. So that would be our period. And the period is how long it takes something to repeat. So if we stayed on this ride for a while, we would get back to that low point every 40 seconds. So T is 40. Let's go ahead and convert that into omega. Over 20. All right, let that adjust. I think we got enough to write this thing, don't we? Let's write ourselves a negative cosine equation. Y equals negative something cosine. We got our omega. Actually, we don't even need a horizontal shift, we said, right? So I can just put omega in front of x. We do need a vertical shift though. So amplitude was 25. Omega was pi over 20. Vertical shift was 30. Sound good? So we want to know when this is equal to, was it again 50 feet above the ground? Yeah, we want to know when this is equal to 50. So calculators, right? I'm going to graph it. We'll graph this function. We'll also graph a horizontal line at 50, and we'll look for this intersection right here. All right, let's see here. I'll set up my window first. That's a wacky looking window. Let's see, my x's, I want to go from 0 to, I think I'll just do one period, so 0 to 40. We'll go up by 5s. Y, I'll go ahead and go from 0 to, it's going to top out at 55. Maybe I'll make it go up to 60. And maybe make that go up by 5s also. That should do it. Cosine. And don't forget your horizontal line at 50 also. All right, let's see if our equation worked out. Oh yeah, that looks great. All right, and as expected, we've got an intersection here, and we'll just use our calculator skills to find it. If you guys figured out that when you do your first, second, and guess, you really don't even need to be right on the point of intersection. You can be quite a ways away from it and it'll still find it. What you don't want to do is be like halfway between two intersections, but as soon as you're pretty close to one or the other, you can just hit enter a few times and it'll search and find it for you. So it looks like about, how many seconds is that? 15.9 seconds, and they should be getting up to that height. All right, feeling okay about that one? If you got questions on 75, I'll ask you to look at the other video that's on the YouTube channel, and that's posted on Canvas.